All right, so for today's Python discussion on text analytics, I want to give you a basic example of how we're going to make use of our term document matrix and how it helps us start to look at unique identifiers within a particular document. And this is really just a preview into where we're going to be going further in the semester, but it really gives us a basic academic understanding of document similarity and also how these vectors created through our term document matrix allows us to be able to apply some mathematics that allows us to compare documents and find similar ones. So let's continue. By the way, I want to share one thing is I have a count vectorizer example here in our notes, and it is a completed count vectorizer example. I am not going to be creating a video on this, so 4-10 should be available for you in the class download, and just know that it is just for your reference, so there will not be a video for that particular lecture. Today we're working on 4.2 document similarity, so let's go ahead and get started. So let's go ahead and execute our block of code, our initialization block. And also I'm using the same sample corpus that we had from our earlier example. And this is all about the sky is blue, beautiful, etc., etc. So if you remember, these blanks should be corpus, and the other one for the category should give us the labels, and we'll be able to display all those pieces. So what we want to do is imagine, if you would, that you have all of these documents. They're already in a category, and we want to be able to basically see if we can create a machine learning tool that when it sees one of these documents or a similar document, that it can predict what category it can go in. So here's how we will go about that. And if you do recall, let me kind of go back over here. If you do recall, this is actually part of our basic analytics process. We have established our corpus. We're going to pre-process the text. We're going to create a term document matrix, and then we're going to extract some information. And just imagine that extracting that information is finding out which particular documents are similar. So here, what we're going to do is we're going to do a small prediction type tool that will allow us to categorize documents. So let's do some basic pre-processing. This is the same as before. If you remember, we used that word punct tokenizer. We're going to corpus We're going to use the NLTK English stop words, and here is that basic normalization function. And if you remember, we are going to use the NumPy vectorizer tool on that particular function. So we'll just do normalize document. There we go. And let's just go ahead and execute it, make sure that it got put into our memory. So we can see the normalized corpus. We are going to go ahead and use our normalized corpus tool. Hold on one second. Where's my notes? There we go. Normalize corpus tool. And we're going to apply this to our corpus. And then that will give us a clean set of documents without stop words. It's all been made to lowercase, no special characters. And now we're going to create that TF-IDF. Now, if you guys recall, there are two ways of doing this. We can use the TF from sklearn. We can use the feature extraction tool, right? And we can import the count vectorizer. And then also with the count vectorizer, we're going to import another tool, which will be the TF-IDF transformer, right? So this is one approach we can do. All right. So as we've done before, we create a count vectorizing tool. We apply the fit transform options to that tool, specifically on our normalized corpus, and then we convert it to an array. Now, since we created a vectorized tool using the count vectorized tool, we now have to use a transformer. So now using the TF-IDF transformer, we create a transformer object. We fit transform the matrix, the CV matrix specifically, and then we convert that to an array. And then our vocab is we're going to get feature names out of the original CV matrix, and then we are going to look at all those pieces. So I'm going to actually take the TT matrix, put it here, and this will give us a TF-IDF matrix of everything. And this we did a little bit in the previous lecture, and if you remember, we could actually use the TF-IDF vectorizer tool instead, right? So if we did, instead of the transformer, we can do this directly by using the TF-IDF vectorizer. I've already filled everything out, but that is just a slight review. Now, each one of these rows creates a vector that represents a specific document. Like this first one represents document 0. And it's actually with respect to all of the words that are in a corpus. And it's based on the weighted features or the weighting for each token that is in that document based with respect to the document and with respect to the entire corpus. So here we can see that first document, the word beautiful and the word sky rate the highest, and they are probably the most descriptive words for that document with respect to the rest of the corpus. Right, and you can kind of go through all those pieces. But what we can do with a vector, right? So a vector we can actually plot into a multi-dimensional space. Now this vector does have many dimensions to it, but imagine if we were, for example, just to plot a basic vector in 2D space. And let's just think of 2D space in terms of what we can represent on a flat sheet of paper. So what we're going to do is we're going to focus on what's called the distance of similarity. And remember, the distance of similarity is not the same as cosine similarity, but it's close. And it must satisfy these mathematical principles. Just to let you know, basically the numbers have to be greater than or equal to 0. And if they are equal to 0, basically they're the same. Distance measure should be symmetric, which means that the distance from x to y is always the same as y to x. And last, this actually says that the distance should satisfy the triangle inequality property, which basically says that 2 legs added together always have to be longer than the third leg, right? And the whole idea is that you can't have 2 legs of a triangle that when added together are shorter than 1 leg, because then a triangle can't be created. All right. So this allows us to get a distance metric. Well, cosine similarity is really taking each of these particular vectors, right? And where a distance metric might look at the point difference at the end of each arrow, that would be the distance metric, right? The cosine similarity ends up becoming the angle between those 2 vectors, right? So if the angle is small, you can see this in the first drawing on the left, we can get an idea that vectors might actually be equal. If a vector is at closer to 90 degrees, we can say that they are not similar. And then, of course, if they are to 180 degrees, as on the far right drawing, well, this is closer to -1, and they are absolutely unrelated to each other. And they're opposite of each other, right? So what we're going to actually do is take the vectors of each document and compare it to the vectors of other document, and then calculate a cosine angle between the two documents. Now, with multidimensional matrices, right, we can vectorize a matrix using basic mathematics. We may not be able to draw out the multidimensional matrix, but we can create a simple matrix that looks like this. And here we would see where document 1 in relationship to itself should be equal to 1 in terms of cosine similarity. And this is based on the identity rule that we have from our cosine similarity rules. And that makes sense. Document 1 is an exact duplicate of document 1. But now we can see in the next example of comparing document 2 to document 1, we see a cosine score of 0.343. And what this shows us is that that is the relative similarity between those two documents. And then the last one between 3 and 1 is that document 3, it has a relativity score or cosine similarity score of 0.455, which tells us that document 3, it has that level of similarity to document 1. Now, looking at our example documents here, we can see that document 1 says Professor Plum has a green plant in his study, and document 3 says Mr. Green has a green plant. We can see the phrase has a green plant is very similar, which could probably explain why our cosine similarity scores are showing that those two documents have a lot of relationship. Notice that document 2, the only thing that document 2 shares with the other is green plant, which is why it tends to have a lower similarity score. So let's take a look at how we can create this in sklearn. It's actually very easy. We are going to use a tool that is called the cosine similarity tool. So we're going to use metrics pairwise, and we're going to import cosine similarity. And let's go ahead and create a cosine similarity matrix by simply using that cosine similarity on our vectorized matrix, which in this case was our TV from up above, right? And I already have all the pieces in, so we can make a data frame out of it. And here's what it looks like. So based on our 8 particular documents that we had, this is our cosine similarity score. And one thing that just pops out to me is I see this one right here, 5 and 7, and it has a cosine similarity score of 0.9. And notice that we have a reflection or an equal cosine similarity down here because this is also 7 and 5. So really, when we look down the diagonal, right, you could see that they're all 1s. So we can look at what documents are very similar. By the way, we can also see that document 7 is highly related to document 2, right? We also see that document 2 and document 5 are highly related. So we can think 2, 5, and 7 probably have high similarity. In fact, let's go back up to our document. So 2 is quick brown fox, 5 is more brown fox, and 7 is brown fox. So that's how these matrices work together, so that way we can identify similar documents. All right, so what do we do with this? Well, with this, we can start to look at other ways of being able to apply this matrix scoring in topic modeling, as an example. And later we're going to get into topic models, but I just want to show you a couple of tools and how we use this in basic text analytics. So first, we're going to use something that's called latent Dirichlet allocation. It is a mathematical tool. You can read about it. You can probably ask your math teacher about it. I won't be covering it in this lecture. But to apply the latent Dirichlet allocation algorithm, we just simply create an LDA object, which is here on line 4. Guess what? We have to do a fit transform again. So we're going to do fit transform based on our CV matrix. And we're going to get these features of this LDA tool, and we're going to see what that looks like. So it's going through and running everything. And what this actually does is it creates a relationship between each document and what potential topic it might relate to. Now, if you look right here, I've actually changed the number of components to 3. By the way, I have a note here. Depending on what level, what release of sklearn you're using, this may be components, this may be topics. So just double check if you're getting an error. You might have to run line 3 and comment out line 4 to make things work. But I identified that there's potentially 3 topics here. And here we can see that we have in topic 1, document 6 is heavily related to topic 1, document 1, and also document 0. Now, if you look, document 2, 5, and 7 all load up on topic 3, which we've seen before just by looking at the TF-IDF values and the cosine similarity scores, then we can see that, obviously they are related to the same topic. So now what we can start to see is looking at the LDA matrix scores, we can see how closely related certain documents are simply by the contents of their of each particular document using a TF-IDF matrix, right? All right, let's kind of look at this in a different way. I have pieces that will allow us to look at what words are most unique per topic. So not getting into all the nitty-gritty of how this works. I just want to share this with you. We will cover this more later in the semester. But here we can see each topic, and we can see each word that goes into each topic and helps kind of explain those topics. So the first topic, in this case, topic 0, was most explained by the word sky blue, beautiful today, and love. Now, if you look, topic 1 also has the word love, and it's actually weighted the same, but it's also joined by other terms as well. And we can see this in topic, the final last topic. So one of the ways that people look at these topic scores with words or topic descriptive words is that they might pick the first 3 words in each column to say that these are the most descriptive words for those topics. But we can still see like how each word is weighted. So another way of doing this is, say, take the top, 10% scored words relative to all the others. And if you look, there's kind of like a flat line at 1.33, right? And we can see over here 1.33. So a threshold score might be anything above 1.4, right? Equal to or above 1.4. And that might give us another way of looking at what words are really most important for that topic. So that's how we're using matrices for topic analysis. Let's look at k-means clustering, and then we'll be done here as well. We can use k-means clustering simply by you looking at the state of the matrix. So here we have on line 3, we're creating a k-means matrix tool. We're going to fit transform our features that came from the LDA document. Notice that where did features come from? Here it is. We have this matrix that came through, right? So this is that particular matrix. We're going to just go ahead and drop this into our clustering to see how pieces go together. And let's go ahead and create, we're going to add our corpus data frame to these clustering labels and see how the k-means clustering can help us predict what category they might belong to. All right, so here we go. Using our latent derelict allocation, our LDA tools, we are able to come up with a weighting score for each topic and how each document is related to that topic. We also were able to use our LDA to figure out what words are probably weighted the heaviest for each topic. And using k-means clustering, it allows us to create a prediction as to what cluster of a particular document might belong to. And so we can see here, and the k-means clustering basically helps us interpret the LDA output. We can see that documents 0 and 1, as well as document 6, belong to cluster 2. Document 2 and 5 and 7 belong to cluster 1, and these two in the middle belong to cluster 0, and you can see they easily match up with the original category that they were designed for. So this is a quick application lecture as to see how we're putting all of these pieces together and how it allows us to be able to evaluate different documents. So I hope this was helpful to you. I hope this kind of gives you some insight as to where we're going with text analytics. So once again, if you have any questions, please see me in class. And until then, you have a good day.